Hello everyone. Please don't forget to fill in this top part right here, first and last name, and whatever date you're taking these notes. Today we are going to hopefully review writing and comparing numbers in scientific notation. Hopefully you're coming into class with a good understanding. So just a quick review. So simplifying 10 to the third, we just got out of the exponents unit, and exponents are so important in this, especially powers of 10. So 10 to the third means 10 times 10 times 10, which is 1,000. But remember, with that negative exponent, we have to open the door, bring it down. So it's 1 over 10 to the third, which is 1 over 1,000. So here you're multiplying. If you had this one, you'd be multiplying by a fraction, which makes the number smaller. So negative exponent makes the number smaller. Positive exponent makes the number larger. So numbers that do not contain exponents are written in standard form. So when you have a very small number or very large, here I'm going to erase that number, when you have very small or very large numbers, it can be difficult to keep track of the place value. So that is why we use scientific notation. So it is the application to exponents and one of Miss Egan's favorite things in the whole world. So scientific notation, again, is just a short way to write very large or small numbers, and you write it. It's always going to be some number times 10 to some sort of exponent, where a, the coefficient, because this is a times 10 to the b, so this is the coefficient, is less than 10 but greater than 1. Always, always, always. So there's just going to be one decimal place before the decimal. So writing each in standard form. So 8.9 is being multiplied by 10 to the third, which is 1,000. So what we know about multiplying by powers of 10 is that for every power of 10, you move the decimal one place greater when it is a positive number. So how I do this is, well, we know 8.9 times 1,000. We can do that math, but I tend to write it like this and just go over. There's the exponent is 3, so I'm going to go over 1, 2, 3, and then add in my zeros as placeholders. So 8.9 times 1,000 is 8,900. This one is a negative exponent, so that means we have to make the number smaller because we're really dividing or multiplying by that fraction. So again, I write my number down here, and then I move it 1, 2, 3, 4 places. That's my new decimal, and I'm going to put in my zeros. So 0.00072. I always go back and double check. So here, if my decimal was here, I had to move it 1, 2, 3. That looks good. My decimal was here. I had to move it 1, 2, 3, 4 to the left. Writing in standard form, the only tricky part, because we know that it's going to be some number times 10 to the some exponent. So one part that you have to remember is that a has to be less than 10, but it has to be greater than or equal to 1. So it has to be in between there. So you're going to place that decimal in between, or you're going to move it to where there is only one number, one digit in front of the decimal. So here we can keep moving and I'll go back and count, but here's where we would have to stop because we only want one digit in front of the decimal. So we know it's going to be 8.9 times 10 to the something. We know that the exponent is going to be positive because this is a really large number. So 1, 2, 3, 4, 5, 6. We would have to multiply 8.9 times 10 to the 6th power to get this number. So again, 1, 2, 3, 4, 5, 6. And then that's where we're stopping the decimal. So for this problem, we know we have to have only one digit in front. So the decimal is going to move all the way down. I like to put a 0 after. If you just had 6, that's completely fine, like I do here. So times 10 to the what? Well, this is a very small number. So we know we're actually going to need to multiply by a fractional part. So we had to move the decimal 1, 2, 3, 4, 5, 6 places. So it'd be times 10 to the negative 6. Because remember, that negative number means that it's fraction. All right, for this next part, explain which value is greater without converting. So because we know that we are multiplying by a power of 10, we should first look at these exponents. The greater the exponent, the greater the place value of what we're multiplying by. So here, 10 to the 21st has a greater place value of what we're multiplying by. So this would be the greater number because 10 to the 21st is a larger number than 10 to the 18th, so we will multiply by a greater number. Unlike this next one, my exponents are the same. So if the exponents are the same, we're multiplying by the same number. So exponents are the same, so we need to look at the coefficient I think that's spelled wrong. We need to look at the coefficient or the number that's being multiplied. So we have 5.1 versus 5.01. Well, this is in the tenths. There's a 1 in the tenths, so you always start at the front. 5 and 5 is the same. 1 and 0, 1 is greater. So that means 5.1 or 5 and 1/10 is greater than 5 and 1/100th. So this one right here, 5.1 times 10 to the 8th is greater. So we can say, so 5.1 times 10 to the 8th is greater. All right, what I would like you to do now is pause, and I have this mixed review. I want you to complete these, and then that's what's going to be checked off. So if you're in class and you're watching the video, we're going to be checking this off. If you're at home, we're still going to be checking it off. If you're just watching this on your own, then come prepared to show me your answers. All right, peace out.